Welcome back. This video is going to talk about angle bisectors in triangles. First, let's learn angle bisector theorem. It says that if a point is on the angle bisector of an angle, then it is equidistant from the sides of the angle. So, for example, if this ray BF bisects angle DBE, meaning it cuts it exactly into two congruent angles, then this point F, since it's on the angle bisector, if we measure to the side of the angle, which remember we must measure along a perpendicular, then these two segments would be equal. The converse of this theorem is also true. So basically, if you know that a point is equidistant from the two sides of the angle, then you can conclude that the point is on the angle bisector. Let's use this in some problems. It says find xy. So I see that ray ZX is an angle bisector of angle YZW. Therefore, point X must be equidistant from the sides of angle WZY. So in order to measure to the sides, I have to measure along a perpendicular. I see that these two segments, XW and XY, are perpendicular to the sides of the angle. Therefore, XW must be equal to XY. So I know XY must also equal 7. All right, for B, I see that segment JL and segment LM, they are both coming from point L, and they are both perpendicular to the sides of angle JKM. Therefore, point L must be on the angle bisector of angle JKM. If it's on the angle bisector, it means that ray KL must be cutting angle JKM in equal parts. So if the measure of angle MKL is 37, that means that the measure of angle JKL would also have to be 37. Finally, we could do some problems like this with algebra 2. So this says find SP. I see that point S is on the angle bisector of angle MJP. Therefore, it must be equidistant from the sides of the angle. And I see that SP and SM are both perpendicular to the sides of the angle. So that means that those two segments are measuring from point S to the sides of the angle. So therefore, MS must be equal to SP. So I can set up an equation. 3x plus 5 has to be equal to 6x minus 7. In order to solve this, I will add 7 on both sides first. Next, subtract 3x on both sides. And finally, divide both sides by 3. You should get x equals 4. However, they asked us for SP. I know SP is 6x minus 7, so I can substitute in 4 for the value of x. So I get 24 minus 7. So I know SP must be equal to 17. Pause the video and try the practice problems below. Here are the correct answers. Similar to yesterday, you don't have to include all these explanations. I just did that so that you would understand where I'm coming from. Next, let's talk about what's called in-center theorem. So the in-center is where all the angle bisectors of the triangle intersect. What we know about the in-center is that it is equidistant from every side of the triangle. So for example, if point P is the in-center of triangle ABC, because it's where all the angle bisectors intersect, then I know that point P must be the same distance from side AB as it is from side AC, measured along PE. And finally, that also must be the same from point P to side BC, which is measured along segment PF. So I know PF equals PD, which also equals PE. A fun fact about the incenter, since it is equidistant from every side of the triangle, I know that these could each represent a radius of a circle, since they're all equal. Therefore, the incenter is the center of a circle that is inscribed in the triangle. So I like to remember incenter, inside. Let's do another practice problem. This one's a little more difficult, so stay with me. First, it says to find JF. JF is this segment here. I know that JF must be equal to JD and JE because point J is the incenter, so it must be the same distance from every side. Notice that JF, JD, and JE are all being measured to the sides along a perpendicular. So, I don't really have enough information to find JF, but I do have enough information to find JE. If I look at triangle JEA, I see that it's a right triangle. And I know two of the sides, 15 and 12. So I can use Pythagorean theorem to say that JE squared plus 12 squared must equal 15 squared. 15 has to be the value of C because it is the hypotenuse. It's the one across from the right angle. To solve this, I'll simplify. First, square 12 and 15. Next, subtract 144 on both sides. And finally, square root both sides to get JE by itself. Normally, we need to take the positive or negative square root, but in this case, since it's a side of a triangle, we only need to take the positive. All right, so I get JE equals 9 because I know the square root of 81 is 9. If JE equals 9, that means JF also equals 9. There are no units provided here, so we can just leave it as 9. Next, it says find the measure of angle JAC. JAC is this angle here. Let's think about it. If point J is the incenter, it means it's where all the angle bisectors intersect. So that means ray BJ is an angle bisector of angle DBE. So if angle EBJ is 34, that means angle JBD would also have to be 34. Similarly, since angle DCJ is 32, I also know angle JCF would have to be 32. So I can label these as the same variable, since I know that they have to be equivalent. So what I'm going to do, I know that in my large triangle ABC, the angles must add up to 180. So I can take 2 times 32, that will give me the measure of angle DCF, plus 2 times 34, that will give me the measure of angle DBE, plus 2 times x, that will give me the measure of angle EAF. And I know that all those angles should add up to 180. So now I'll just simplify. Combine like terms. Next, subtract 132 on both sides. And finally, divide both sides by 2. Since x is 24 and we used x to represent the measure of angle JAC, I know that the measure of angle JAC must be 24. Pause the video and try the practice problem below. Here's the correct answer for A, and I'd like you to answer B on your own. That's all for today.